This week we're going to continue with object-oriented programming, but we're moving on from the basics of abstraction and encapsulation, and we're going to be looking at inheritance as our next pillar, basically. And then, of course, we'll go on to polymorphism and the last pillar. But for your first phase of your assignment, we're not looking for inheritance yet. If you want to, go ahead and pre-design your objects to use inheritance. But we're going to be grading mostly on abstraction and encapsulation in your design for the first phase. Okay? So just very quickly here, just as an introduction, because I'm going to do most of this tutorial style. Inheritance is a mechanism in object-oriented programming whereby objects can be extended to subclasses. So you've got superclasses and subclasses. And you've got subclasses that inherit behavior from their parents, just like a parent-child relational diagram. And they inherit both state and behavior from their parents, depending on how you design them. Once you're in the subclass, you can also override or augment behavior and state in order to get more specific functionality. Right? Now, here's an example. Here's kind of a motivating example in the Java collections library. Now, this is a simplified diagram of how the collections work, but you can kind of see that this is a superclass up here, and then we've subclassed it to multiple subclasses. Those subclasses have been subclassed further. Up here, we've got a very general collection, right? A collection is just something that holds stuff, right? It doesn't say how it holds stuff or the functionality that it necessarily provides, etc. There are two subclasses that are common in the standard in the collections library: a set and a list. The difference between these two is that a list holds stuff in an ordered manner. There's a first element, there's a second element, there's a third element, and it's indexed. You can get these element at index I. But the set is a subclass that holds stuff in not any particular order, right? And it also provides a little bit more specific behavior in that a set only holds unique elements. So up here we've got a very general notion, very general idea of a collection, just a box, right? A box that holds stuff. You can make that more specific by saying that this is a collection that holds unique stuff, or this is a collection that holds stuff in an ordered manner, right? So already you've got more specific behavior. You can subclass that even further. For example, the one on the right. There are two types of lists that you can use. There are several, actually, types of lists that you can use, but the two major ones are the ones that I've showed you already, an array list, and then also a linked list. So if you want to look at it in the most specific kind of way, then an array list is a collection that holds stuff in an ordered manner because it's a list, and it does so using an array under the hood. A linked list uses a bunch of linked nodes instead of using an array. So most general behavior, more specific as you go down through this entire hierarchy. Right? Inheritance is it provides a way to reuse code. It provides a way to organize code. Right? Those are the two big pluses for using inheritance. You can go overboard and Yagni, right? You're not going to need it. You ain't going to need it. But we'll keep it simple. And I'll talk about the pitfalls later on. Okay? It provides a way to reuse code because if you've got common code, you can go ahead and put that up here in a superclass, and all of your subclasses will inherit it automatically. You only have to write it once, and all of these classes inherit that behavior. It provides a way to organize code. We do this all the time, right? Because to think about a very complex world of ideas, usually we try to organize them into some sort of a hierarchy. I was trying to remember the mnemonic device for, let's see, what is it? Domain, kingdom, phylum. What else is there? Order, genus, species, right? The organisms on this planet are organized in this hierarchy of orders, right? The most specific or most general up here, and then the most specific way down here at the bottom, species. We do this with file systems, right? File system. If you start at the root file system and then you go down to subdirectories, those directories have subdirectories. Everything you want it to be a tree. because it allows you to focus only on one thing at a time, and then it also allows you to organize it under a hierarchy so that this thing, it's a reptile, so it belongs over here in the reptile kingdom or whatever, right? And so if you want to focus on a kingdom, then you're only focusing on reptiles, and you can focus further or down the hierarchy. I don't know anything about biology, so order, genus, etc. Right? It is a way to organize code as well. So to understand this a little bit better, let's go through a demonstration. What I've done here, now this has nothing to do with your assignment, your project. Even though I'm doing an account, it's not necessarily it doesn't necessarily have a one-to-one correspondence with your assignment. There are good design principles that I'm going to show you here, but it's not necessarily something that you want to copy here. All right? I've got a savings account, the concept of a savings account. Well, every account is going to have an ID, and I've chosen to model that using a string because you can have dashes, you can have letters and account numbers in some banks, etc. It's got an owner, which is a person object. Person has a first name, a last name, a social security, a date of birth, an address, etc. Right? Well, what is an address? City, state, city, street, city, state, and zip, right? Just like we did last week when we were looking at airports and talked about airport addresses instead, right? What kind of a relationship is this, right? We did all this stuff before we even started talking about inheritance. When one object owns another object, that's called, remember? It's composed of other things. It's composition, right? That this person is composed of 3 string objects, a local date object, and an address object. The address object is composed of other further objects, right? So remember composition, because it's kind of an alternative to inheritance. Okay. All right. So we've got an owner. We've also got a balance and an APR, because if you put money into an account, that's your balance. If you've got $100 in there, you can make a deposit, you can make a withdrawal. This is a savings account, so it also pays you interest. Every month, if you've got a 1% APR account, or let's make it simple, 1.2% APR account, then you divide that by 12, and each month you're earning 0.1%. Multiply that by your balance, and that's how much money you earn that month. That money gets added to your balance each month. Okay. So really quick reminder of how you design objects. Once we've designed this object, then what should I do? I should probably go up to source. Let's see, create a constructor using fields. To keep it simple, I just want the account ID and the balance and the APR, let's say. Okay. Let's generate those. We can go up to source, generate getters and setters. I'm just going to do all the getters. Right? We can go up to source, generate toString method, and I'll only do the account ID and the balance for now. Okay, and then of course you can come back here and change it. I'll go ahead and put in account ID and then plus and a $sign here, and then the balance, and then I'll end it like this. Right. So this is a pretty quick and dirty design of my object. Over here, let's go ahead and create 3 versions of this. Let's say that the APR is going to be, 1.2%, like I said. Another one with 3.5%. And another outrageous account of 15%. Okay. Now these are on the scale 0 to 100. There was already a question on Piazza about this. What's the proper scale? Right? Let's decide that now. How should we scale that? Should this APR be on 0 to 1, or should it be on 0 to 100? Because over here, the way that I've created them, they're clearly on 0 to 100. Right? Nobody's going to pay 120% interest on your account. Sign up with that back, or 150% interest on your account. Right? So how should we model the APR? Preferences? No? 0 to 1? Okay. I'm going to document that here. Right? The APR, the annual percentage rate on the scale, 0 to 1. All right, and that's going to change the way that I create my objects over here. Now, 1.2% is going to be actually 0.01, and then divide by 100, right? 0.035. And 15%, that's still outrageous, is going to be 0.15. All right? So I've got 3 savings accounts here. And I can print them out. System.out.println S1, right? S2, and S3. Just making sure that everything works, compiles and runs. Looks like we've got $100, $50, and $1,500, and those are the account numbers. Okay? I'm doing some mock data here. Again, you should be focusing on testing your first phase. Every phase from now on is going to have some testing associated with it. You should be putting that in your design document. I went to mockaroo.com and generated 100 instances, right? That should be in your design document. Okay? All right, this is great. I can also, provide some functionality. For example, what I described before, that I can have a public double get annual earnings. Right? So I want to know how much money I'm going to have in this account if I leave it alone, don't make any deposits, and 12 months of compounded interest. Now for that, I'm just going to go ahead and cut and paste what I've already done over here. That I want, it's going to be, actually, let's go ahead and document that. All right? Returns the amount of earned interest in 1 year. Or year, there we go. Amount of expected interest in 1 year, which is going to be the balance times the annual percentage yield, right? Because it's compounded, right? Every month you get $5 that first month, right? Now your balance is $105. You get and now the next month the interest is compounded, and you are earning interest on that additional $5. Now there's a very simple formula for this. All I'm going to do is going to cut and paste here. The way that you compute this is this dot balance times. You take the interest rate, divide by 12 because that's your periodic rate. The APR, the annual percentage rate. This is your monthly percentage rate, and then you raise that to the power of 1 plus that, and then up to the 12 periods, the 12 months that you've got, and then subtract 1, right? Because then it'll be like 105% and some change, and so you take off the 100% and you get back to this. This is your annual earnings, right? Oops, I need to return. There we go. So let's see this in action over here in the demonstration. I should expect like $12, right? $1.20 and maybe some additional here for the first one. So system.out.println s1.get savings account get annual earnings. There it is. Right. So I would expect about $1.20 plus a little bit more because of compounding interest. So there we go. We can go ahead and round that off too if you want to. So you get 1 extra penny beyond that because of the compounding. Not that big because it's only $100 and it's only 1%. Right? But that's a pretty good design for a savings account. Now, what other kind of accounts might there be? I think I heard it. Stock account. Okay. That's your project. Think about just consumer accounts. You go to Wells Fargo, you open up a savings account. What else? It's kind of obsolete, in my opinion. I haven't written a check in 10 years, I think. Only like old school businesses that require checks, or they don't allow you to use a credit card or cash or something like that. You'd have a checking account. Okay. So let me go ahead and create a new class to represent a checking account. There we go. And you know what? What is a checking account? A checking account is going to have a number, right? So private string account ID, right? Private. It's also going to have an owner, person, owner, right? And it's also going to have a balance, right? Double balance. Seem familiar? Right. What am I doing? I'm just reinventing a savings account. But a checking account doesn't pay. Some checking accounts pay you interest. We'll go ahead and assume that this checking account doesn't. Instead, you deposit checks. And in fact, it's a terrible checking account because it also might have fees, right? Annual fees or monthly fees or something like that. But it certainly has an account ID, an owner, a balance, all these things that are common to a savings account. It does not have an APR because it doesn't pay you interest, we'll say, for this terrible checking account. But it does have, say, monthly fees. Right? I don't know, does anybody have a checking account with monthly fees? Annual fees? All right, no? Okay. Yeah, don't get one of those. We'll go ahead and say that this is a terrible bank. It's a Wells Fargo bank. And double, annual fee, right? So we've got some things that are common here, right? An account ID, an owner, and a balance. We've also got some things that are not in common, an APR and an annual fee, right? So this is a perfect opportunity to use inheritance so that we don't have to reinvent the wheel. All this stuff that I have over here, all these getters, all these setters, the constructor, everything else, the state definition here, I don't have to do that in two different classes. Because imagine if I did that, if I just did a copy, paste, copy, paste, copy, paste. There's also certificates of deposits. There are also, what is it? Not an IRA. That's a retirement account, but there's also a money market account, right? There are a bunch of other different types of deposit accounts here, right? So what we should do is we should generalize this concept. Let's go ahead and create a new class called a, let's see, what should we call this? Bank account, right? Or just account, right? I'll go ahead and go with bank account here. And I'm going to see that, well, these three things are in common. So what I'm going to do is I'm going to promote them up to the superclass. Right? All bank accounts have, an account ID, an owner, and a balance. Whether or not they're a checking account or a savings account or an IRA or whatever other kind of accounts you want to model here. This is all the common state. What's uncommon is an annual fee, because not everything has an annual fee. A savings account doesn't have an annual fee. And an APR, not every account has an APR. Right? So what we're going to do is we're going to define more generally what a bank account is. And I'm going to go ahead and go back to the savings account, and I'm going to move these things over. I'll move this stuff over. Actually, let's try moving all these things over. Right? So all those getters and setters, get account ID, get owner ID. Maybe I want to generate a constructor here, so I'll go ahead and go back to source, generate constructor using the fields, and I'll go ahead and just go with account ID and balance for now. Right? There's my nice constructor here, and of course, put in a to-do document this. Right? And I'll come back later and do that. I've got a getter there and a getter there, but wait, an APR? Does a generic bank account have an APR? Nope. So, more specific stuff in the subclasses, more general stuff in the superclasses. Two-string, that'll be fine. But do we have get annual earnings in all bank accounts? No, because we don't have an APR in all bank accounts. So this is not something that belongs in the superclass either. Right? There, I've defined a generic bank account. Now what I want to do is I want to eliminate this redundancy here. What I'm going to do is I'm going to make a checking account extend the behavior of a bank account. Extends is a keyword in Java that makes a subclass. These subclasses over here, collection, set, these are actually interfaces, but don't worry about that yet. Hash set extends set. It actually implements set, but we'll talk about that later. Right? The way that you subclass something is by saying the superclass up here is extended by its subclass, or the subclass extends the behavior of the superclass. Now it's still complaining here. Well, let's see why. We need to add a constructor. Let's see, string. Okay, we'll go ahead and do it, just because it was complaining. Right? And the reason that it wants a constructor here is because it's superclass. Now bank account is the superclass, and checking account is the subclass. The bank account here has a constructor. It needs to be constructed with an account ID and a balance. You need to call that superconstructor. Right? Remember when we called a regular constructor, we used the this keyword, right? Or from outside the class, we just said new. Super is a keyword that refers to the superclass. Right? And then finally, we also want an annual fee, double annual fee. Right? And then this dot annual fee is equal to the given annual fee. Right? And now everything is defined in this. It does not have an APR, but it does have an annual fee. Right? Now the redundancy is limited here because we only have what's unique to the subclass in this demonstration. Right? Let's do the same thing for a savings account. We can get rid of all of this stuff, except for the savings account. There we go, balance and then APR. And then I can refactor this so that we call the superclass and then the balance. I think that the account and balance is all we have, right? Well, we haven't extended yet. So extends bank account. There we go. And we can get rid of this redundancy right here. The APR is the only thing distinguishing a savings account from a bank account or from a checking account. And now we've got a nice little three-class hierarchy here. Up here we've got the generic bank account, and down here we've got these two children that are a little bit more specific. This one is a checking account, this one's a savings account. This one allows you to write checks and it costs you an annual fee. This one allows you to save money and it pays you an annual interest rate. Right? Okay? And then we've all, but there's a problem here. Right? What about balance? This dot balance. Right? So do you see any balance here at all? No. Does that mean that there's no balance in a savings account? Remember, we're extending a bank account. It means that we inherit everything from our parent. Savings account here is a child of bank account. Bank account does have a balance. So there's a balance here somewhere. Why are we not able to access it in the subclass here? Any guesses? It's private. Right? What does private mean? Only the class can see it. In other words, I'm in the bank account class and I've got this balance variable. Only I am able to see it. So my child, can it see it? No. So we need a way to give the child a way to access the balance for this class. Now, the way that we've already done that, right? We've already got a getBalance function. Right? That's one way. We could control everything through getters and setters. So this object's balance, which is inherited from your parent, you have access to it through the getBalance method because it's public. Anybody can see it. Anybody can use it, including the subclasses. The alternative, let's go back to savings account. The alternative is to not use this. Well, actually, this dot balance. Yes, use this dot balance. But the alternative is to change the visibility of this. Private is the most restrictive visibility. Only the class can see it. Public is the least restrictive visibility because anybody can see it. We don't want to go that far. We could, of course, go that far and make it public. Right? I don't want to do that because that's now a mutable, basically a global. Globals are evil. Anybody can change the balance. We have to test for the eventuality that everybody will change the balance. I don't want that. I want somewhere in between. So what I'm going to do is I'm going to make it protected. Protected means that subclasses can see the variable. And you can see over here in the savings account, it is now resolved. I can directly access this method or this class's balance because I inherit it from the parent, but it's only protected. I can still see it. Right? Now, outside this class, over here in the demo the savings account, I still can't see it. S3 dot balance. Right? I can't see that. Let's set it equal to, I don't know, I've drained your bank account and overdraft. Oops, sorry, it is. Why? Because I'm in the same package. Darn it. Protected, you can still see it in the same package. It's not package protected, so let's move. I'd have to move the demo out to fully protect it, but oh well, you get the idea. I'd have to move this demo to some other package. Let's do that. Let's just go ahead and move it up to the default package. Oh, there's already a demo up there? Okay, fine. Yes. And yeah. Now it doesn't even know about these things. I will import them, though. There we go. There. And now if I try to access that balance, balance. I can't even see it, so it's not even coming up on code completion is equal to negative $10. Now I'm not able to do this because it's protected. If it were in the same package, it could still see it, which is kind of bad. But that's why you make sure that you put stuff in the proper packages. You don't just put all of your classes in one package. Okay? So it's protected, but at least a subclass can now see it. Right? All right, that's pretty good. Let's see. Yeah. So let's review some of what we just covered. In Java, you can create a subclass by using the extends keyword. So it is a verb, right? This class right here extends this class right here. Right? If class A extends class B, then A is a subclass, B is a superclass. Right? Sometimes you also call these things inherited classes or parent class. Subclass can also be called the child class. Superclass can also sometimes be called the parent class because it's got this kind of hierarchy here. These are the parents up here, and then they yield the children down here. The children extend the superclasses up here. Right? That's the idea. The protected keyword can be used to make variables and methods visible to subclasses. Right? Private fields are not visible to the subclass. Right? Otherwise, all public and all methods, I should say, methods and state is inherited by the subclass. Right? Questions on this so far? If I were to generate this is not a UML diagram, which is going to be worth bonus, and you definitely should do that for your design document, but don't draw it out. Just use a tool to generate it. And when you get to, I believe, tomorrow's lab, or maybe it's lab next week, we use it. We recommend a tool in Eclipse to do this automatically. You can generate this class diagram, and you'd have up here a bank account, and you'd have down here these two subclasses. Okay. There's still a problem here, though. Let me come back over here to the demonstration. Now I've got two demos, but I don't know which one is which. Let's go ahead and get rid of them both, and then look up demo. I'll just reopen it. There we go. All right, so I've got a savings account. We could also now create checking accounts, right? Checking account. C1 is equal to new savings account. Is that correct? Is a checking account a savings account? No. Is a savings account a checking account? No, but they are both bank accounts, right? So a checking account, if I want to create a checking account, I should call the checking account constructor here. And I'll go with just XXX. And how much is in there? What else do I need in a checking account? I need the balance and the annual fees. So the balance, I don't know, $1,000 in my checking account, and there's a $25 annual fee. There we go. And I need to import it. That's what it's complaining about, since it's in another package. There we go. And now I've got a checking account. Right? So observation. A checking account is not a savings account. Neither vice versa. That a savings account is not a checking account. But what observation can we make from this inheritance here? Similar to this one over here. A set is what is a set? A set is a collection. What is a list? A list is also a collection. An array list is a list that is also a collection. Right? So we have this hierarchy here defining an is-a relationship. Now, is an array list a set? No, because it doesn't fall in that hierarchy. An array list is a list is a collection, and therefore by transitivity, an array list is a collection as well. But over here we have a completely different family of collections, sets. A list is not a set is not a list. All of its children are its parent, but it's not any of its cousins or aunts or uncles or whatever else you want to call this in this kind of family diagram here. An array list is not a set, and a set is not an array list. Likewise, a hash set is not a list because it's a set. Right? So that defines a hierarchy. A checking account is a bank account. Right? What's the other one? Savings account is a bank account as well. Does the other way work? Is a bank account a savings account? Is that the only kind of account there is? Nope. So it doesn't work in the opposite direction. A list is a collection, but is a collection necessarily a list? No, it could be a set. So this kind of hierarchy here, this inheritance, defines an is-a relationship back up to the parent. Okay? Inheritance defines an is-a relation. Right? A subclass is an instance of its superclass. Right? This is called covariance. Right? But a superclass is not necessarily an instance of its subclass. This would be called contravariance. Right? And I emphasize not necessarily here. In fact, I'm going to emphasize that by marking it up here. It is not necessarily. That's a contravariant relationship. Two sibling, or what else would you call it? Cousin classes are never an instance of each other. Right? This is called an invariance or invariant relationship. To illustrate this further, I'm going to pull up another diagram here. Not that one. Where is it? I thought I had. Oh, yeah, here it is. So here's another relationship. It's a little bit more contrived, but we've got robins and ostriches, right? And they're both types of birds. So up here we've got a very generic type of bird up here. An ostrich is a bird. A robin is a bird as well. Right? But what are the relationships back and forth here? A robin is a bird. That's a covariant kind of relationship. That's always going to be safe. It is always safe to treat a subclass as a superclass. But what about the opposite direction? Is a bird necessarily an ostrich? No. Going down is a contravariant. It could be safe if you had an instance of a robin and you treated it like this is just a bird, right? Then if you forced it to become a robin again, well, that would be safe, but only in that one instance, right? And across these siblings right here, that's an invariant. An ostrich is never a robin, and a robin is never an ostrich. Right? That's the same basic idea of what we just did over here with the savings account, checking account, and bank account. Now, there's an immediate problem here, though. A bird. Should I be able to just create a bird? A generic bird. Is there such thing as a generic bird in the real world? No, everything's an ostrich or a robin or a lark or whatever other bird you can think of. That's all I can think. I've exhausted my list of birds in my head. Right? But is there ever just a bird? No. So, same idea over here. Is there ever just a bank account? It's always an IRA, or it's always a money market account, or a certificate of deposit, or a checking account, or a savings account, right? These are all kinds of accounts, but there's no such thing as a generic bank account. Should we allow people to create a generic bank account? So I'm going to see, can I do that first of all? And I can. B is equal to new bank account. and I don't know what I need here, but what's in a bank account? An account ID and a balance, right? So YYY and $100. There we go. And I just have to import it because it doesn't know what it is. It's from a different package, right? What can I do with this bank account? I could get the account ID. I could get the balance. All bank accounts have balances, right? Otherwise, what are you saving, right? It could be a negative balance and like a loan, right? I can do a bunch of other things. I wonder how that works. But I can get the owner. I can print out the owner. But there's not much else I can do. Is this a bank that pays me money because I've deposited it into a savings account? Or is it a bank that takes my money because I have to pay a fee? Right? I don't know. Right? It's generic. Right? So maybe I don't want to allow this. Right? So the solution is to make it abstract. Right? Sometimes you don't want to allow people to allow by design people to create a particular generic class if it's too generic. For example, over here in this hierarchy here, you cannot create a generic collection because you don't have an answer to the question, how does it hold stuff? Right? Those details are necessary. Well, an array list holds stuff by creating an array and putting stuff into the array. A linked list holds stuff by creating these nodes, putting the stuff in the nodes, and then linking it to the next node, and the next node, and the next node. Right? That's how it actually works on those two classes right there. But a list is just a collection that holds stuff in an order. How? I don't know, therefore I can't create a generic list. Likewise, I can't create a generic collection. Right? So what we want to do is we want to disallow that. To disallow a user to create a generic class, make it abstract. And you can see by me putting that into the keyword, that is into backticks there, that is an actual keyword in Java. You can make a class generic or abstract simply by putting abstract in front of it. Right? Public abstract class bank account. Now, here's the idea, right? It's generic enough that I don't know how to actually construct one of these things. I can't create an actual list or I can't create an actual collection. I can create an array list because once I know that it's an array list, I can create an array and I can put stuff into it and I can take stuff out of it. I know how to do that. If I want to create a bank account, though, I need to know, is this a savings account that pays me money? Or is this a checking account that I have to pay money to it? Right? If it's just a generic bank account, then it's too abstract. I don't know what it looks like. Also, the bird example. What is a bird? A bird is an abstract idea. Right? Go back to that kingdom, phylum, order, genus stuff. Right? I don't know where birds fall into that thing, but there's an idea of a bird, and then you've got genuses below it and species below it. There's no such thing as an actual bird. A bird is just an idea. Right? And by the way, this has philosophical roots. The whole notion of object-oriented programming and being able to create objects, often called ex nihilo or just out of nothing, it goes back to Plato. Right? Plato's theory of forms. Right? So the idea, here's an idea of that philosophy. Is there such thing as a circle? Right? Well, there's an abstract notion of a circle. We can describe a circle using pi, right? A radius is 2 pi or whatever, pi r squared. So the a unit radius is going to have an area of pi. It'll have a circumference, a well-defined circumference, right? But is there such thing as a circle? And I'll preface that by saying a perfect circle in the real world. Right? Now, I'm not even going to try, but maybe even the best artist in the world, if they came up to this whiteboard and drew a circle, would it be a perfect circle? It might look like a perfect circle, but when you get up to it, what is it? It's just a collection of a bunch of smudges of ink. If you were to a computer is perfect. A computer can draw a perfect circle, right? You zoom in on it, and what is it? It's just a collection of pixels. It's an approximation of the real idea, of the abstract idea. That's Plato's theory of forms. there's an idea of the perfect circle. There's an idea of the perfect chair, right? But it's too abstract. When we actually see the forms take place in the real world, then this is one type of chair, and you're sitting in a different type of chair. When we draw a circle, it's just an instance of a circle. It's an imperfect instance, right? It's not the idea. These are abstract ideas, right? And in Java, we use the keyword abstract to make them abstract ideas. And you can see immediately the consequence over here in the demo. Can I create a bank account anymore? No. In fact, there's another way that I could have controlled this is by making this private. And now nobody can even see this, but that's another way. Right? I'll go ahead and keep it public for now. But knowing that you can't even call it because it's an abstract class. All right? So making bank account abstract makes this impossible. Right? And I'll go ahead and comment it out so that it's at least working now. Right? However, you can refer to bank accounts, bank account objects. Right? What I mean by that is bank account B is equal to, let's say, my savings account up there, S1. Right? Bank account B2, I'll reference that to my checking account, C1. Right? Now, ignore all this stuff. What is B1? What is B1? What is it? As far as you know on line 38, if I tried to do something with it, you know that it's a savings account because you saw this code up here, and I'm referring to the savings account. So you know it's a savings account, but does the code know that on line 38? If it were a savings account, what could I do with it? I could get its annual, what was it called? Get annual earnings, right? Can I do that? To print it out? Let's find out. Can I? No, why? The method get annual earnings is undefined for the type bank account. B1 is a bank account. It's a generic bank account, right? Now, as far as the code knows, this is a bird, right? Well, how does a robin move, by the way? Hopefully we know our birds here well enough. It flies. Can an ostrich fly? So an ostrich runs or walks. I forget what I did, but it's 2 feet, right? However it does it. Sometimes it runs, sometimes it walks if it's not in a hurry, right? But the bird up here, does it fly or does it walk? I don't know. So bank account, does it earn me interest or does it cost me? I don't know. And so if you're treating it as its generic type, as its super type, then you can't get specific behavior like this. Okay? So what is B1 as far as the code on line 38 is concerned? It is a generic bank account. We cannot treat it like account. There we go. We cannot treat it like a savings account. We cannot treat it like a checking account because that would be a contravariant relationship. Taking a superclass and forcing it to become a subclass is not necessarily safe. So, what can we do? So, option 1, force it to be a certain type. Right? So what I'm going to do is I'm going to force that bank account B1 to become a checking account or a savings account again. Right? I even forgot what it was. So option 1, I'll force it to be a certain type. Savings account S is equal to B1. That looks kind of familiar. Right? First of all, it's not allowing me to do it, but for a very good reason. An integer and a double. What's their relationship? Is an integer a double? No, is a double an integer? Not really. If I took an integer, could I force it to become a double? Like 2. I could force it to become a double just by 2.0. Right? Can I take a double and force it to become an integer? I could, but what happens? 3.5 becomes 3. Not rounding, truncation. Right? So you can force one type to become another type. And that's what I'm going to do here. Through? How did we do that? How do we force an integer to become a double so that we can divide by it? A typecast. I will force this to become a savings account. Right? Now it's perfectly fine. Well, at least the compiler is happy about it. And now I can do what I did up above. I can, not B1 anymore, but S. There we go. And I can get annual earnings, and it'll actually work. Right? So it's printing out 0. I forget why. What is it? Savings account. Ooh, why is it printing out 0? Savings equals. There we go. Print that out. Savings equals 0. Get annual earnings. Ooh. Maybe, because maybe I never set the balance. Or, no, it's $100 and, oh. I'll have to figure that out why it's, it is savings, right? It should be paying me stuff. So balance, you know what? This is a perfect opportunity. What did I just do? I set a breakpoint. How is this going to help me figure out why it's printing out 0? I can debug it, right? And I can open up my debugger perspective here. It's running. And let's see, we can look at S. S is ABC 123 $100, which is, again, a reference to this S up here, which is exactly the same thing. We can open it up and look at the internals here. It has an account ID. It has an APR, which is set to 0. All right, so there's our answer. The APR is 0. Now I'm going to have to go back and find out where did we ever set this APR when we created this S1. Did we ever set it? All right. So what I'm going to do, here. Let me go back and set another breakpoint over here so that we can look at the creation of this account. So let me go ahead and stop the debugging process and run it again. And now we're at this point. What I'm going to do is I'm going to step into that constructor. We're going to go in here. Oh, oops, I stepped over, sorry. So let's go ahead and do it again, which this one is step into. So step into that constructor. Oh, okay. Fine. Over that. Ah, darn it. Okay, it loaded the class, sorry. Now I'll step into the constructor. There we go. I could have set a breakpoint at the constructor too, and then I could have automatically gotten into there. And it looks like, we called it with the balance and the APR, but then what did we do with the APR? Did we ever do anything with it? So I've got my answer right here. What did I forget to do? This dot APR is equal to APR. Excellent way of figuring out what's wrong. Right? Running a debugger, setting breakpoints, coming up with theories. Well, this is 0, so why is it 0? You set a breakpoint at that point, you jump to that point and you say, okay, well, it's because the APR is 0. All right, well, where did the APR get set? Now I need to set another breakpoint to find and trace through that program to see what happened. I can go ahead and stop now, get out of debugging mode, run this again, and see if everything was fixed. And it looks good. That's what it was from before. $1.20, 20 point, and a hay penny. All right, there we go. Of course, we could go back and we could round that off if you want to. Okay? All right, that's one option. Does that sound like a safe option? What if I did it the other way? What if I did it as a checking account? I forced B1 to become a checking account. All right, well, now I'm not even going to be able to do this, but actually the compiler is smart enough to say that, wait a second, you can't do that. You cannot convert from checking account to savings account. Fine. That's the compiler being smart and saying, wait a second, I know about S1. I know about S1. I know what it is at this point. You can't do something like this. So let's go ahead and try to fool the compiler. Public static foo, and takes in a bank account. Hopefully I can trick the compiler by passing it off to another function here. Foo B1. There we go. And what we'll do is we'll force it to become not a savings. That's because it's S. Sorry, the compiler is not that smart. I'm just missing something. Let's force it to become a checking account. I'll call it C. Right? And we'll force B1 to become a checking account. B1. There we go. Or checking, sorry. There. Now the compiler, okay, I thought I gave the compiler too much credit. I was ignoring the fact that S was already a savings account. So I've got a checking account here. Is B1 a checking account? No. What was it? B1 was set to S1, which is a savings account. So I am forcing a contravariant. Basically, I created a robin, and I treated it as a generic bird, and now I'm going to try to force it to become an ostrich. In other words, I'm taking a robin, and I'm forcing it to become an ostrich. Is that going to work? That's never safe. That's an invariant type. So let me come back over here and see what happens in Java. What do you think is going to happen? I'm not exactly sure. Well, one thing or another is going to happen. There. What happened? I'm glad that happened. Wow, bunch of stuff. Class savings account, there we go, cannot be cast to checking account. They are, don't worry about the unnamed module, blah, blah, blah. That's just additional information here. Right? What is it telling me? It's telling me that I tried to force an invariant relationship. I tried to force a robin to become an ostrich. And unless you're Dr. Moreau and you have a generic or a genetic engineering degree or whatever, and are doing it illegally, you can't force a robin to become an ostrich. Right? So that is going to be not a great option. Right? Option 2, right? Only treat an object as its superclass if you don't need its specific behavior. Right? Or, put another way, redesign or make sure your objects are designed such that all general behavior is defined in the superclass. Right? All specific behavior is defined in the subclass. Okay? So if I'm going to treat it as a bank account, a generic bank account, then I'm not going to be able to do something like this. But I could do, say I really wanted to do that. I wanted to get, all bank accounts have get annual earnings. What I can do is I can promote that up to the bank account up here. Every bank account will now have a public double get annual earnings method, right? And a checking account will have these very specific behavior, the savings account will have the very specific behavior of taking the balance, multiplying by the annual percentage yield, and then returning that $1.20, whatever it was for our example. What about a checking account, though? Checking account doesn't have annual saving or annual yield. Or you could say that it's the annual fee, negative the annual fee, right? Public double get annual earnings, there we go. Return, well, 0 if you interpret that as earnings, or since it's costing you money, an annual fee, right? The negation of the annual fee. Because if your annual fee is $25, then your annual earnings are negative $25. Right? So that's another way that you can interpret this. What about a bank account, a generic bank account? Is there enough information up here in the superclass to determine what the annual earnings are? We could say, I don't know, I'll just return 0. But that seems kind of icky, because what if I created a new class and it inherited this behavior? I created a certificate of deposit class, which does pay you annual earnings. It just pays it on a quarterly basis instead of the monthly basis that savings has. If I inherit this, then it doesn't make much sense. So I have to come up with a compromise here. Right? I don't know how to implement this in the superclass, but I want a public double get annual earnings method for all of my accounts, checking account, savings account, whatever. I want everything to have this method so that I can do it. I can do something like this: bank account B is equal to what, or B1 dot get annual earnings. For the first one, it'll print 0. For the second one, it'll print that $1.20, et cetera, et cetera. Right? I do want this as part of its public interface. The solution is okay, I want that, but I don't know how to do it. The idea is to make this into an abstract method. Right? So we've already got an abstract class here. I can't create bank accounts. And therefore, because if I did create a bank account, I would need to know how do I compute the annual earnings. Well, for one bank account, you do it one way. For a different type, you do it another way. For a different type, you do it a different way. I don't know how to do that for the generic idea. Over here with the bird, if I have an abstract bird class, how does a bird move? It depends on the type of bird. Right? And if it were a robin, then it would fly. If it were an ostrich, it would walk. Right? If it's a bird, I have no idea. That's an abstract idea of moving. This is an abstract idea of you getting money for your bank account each year. So I make it abstract, and you see the consequence here. There's no function body. There's no method body. Right? And I don't have to define one because it's abstract. Okay, I don't know, but if you ever have an actual bank account, a non-abstract subclass, that's when you have to define it. That it's balance times APY or whatever, or 0, or negative annual fee or whatever. Right? So that is how you can create abstract classes. Let me create one more class here to show you why doing this is really nice. What I'm going to do is I'm going to create another, money market account. Class money market account. Right? There we go. All right, well, I don't want to have to reinvent the wheel, so what I'll do is I'll extend a bank account. Right? And now I need to add a constructor. There we go. It also has an APR, so double APR. Right? And then don't forget my last mistake here. This .APR is equal to APR. And of course, I've got to put that in as a private double APR. Right? Now, it's still complaining. Why is it complaining? If you can read that, it says, the type money market account must implement the inherited abstract method get annual earnings. Right? So I've extended bank account. So it's like I've created another bird over here. Give me another bird. A penguin. There we go. Penguins are technically birds, right? So I've got penguin over here. How does a penguin move? Waddles. Good, right? Because I didn't want fly or walk anymore. It waddles. So if I created another third child here, I would have to define that it waddles when it moves. I've created another bank account here. I have to define how is the annual interest computed. Well, for money market accounts, let's suppose that it's like savings accounts, but instead of every month, it's every quarter. So I'll cut and paste that, and instead of 12, it'll be every 3 months, right? 4 times a year, every quarter instead. So it's a little bit different, more specific behavior, slightly different than its sibling. Right? But I didn't have to recreate everything. Right? And I made it abstract so that I remembered that if I don't specify the actual behavior here, right, the compiler warns me about it. Well, it tells me about it that you've got to actually define this stuff. Right? And that's a nice little way of doing it. Right? You can also have what are called interfaces. Interface, right? Let's see, interest bears, is that right? Interest? Is it bears, B-E-A-R, or is it bears, B-A-R? An interest-bearing account. I think it's A-R, isn't it? E-R? Okay, I was right. Cool. Bears interest, right? Well, if something bears interest, then that means that you've got a, let's see, let's go over to bank account here. It's got this thing here. It's got a public method that get annual earnings, right? And I don't need to make this abstract, right? This is kind of like the bank account up here, right? But instead it's what's called a pure abstract class. It's an interface. If I created an abstract class such that it only had abstract methods, then I'm basically only defining what something is. That's kind of like a collection. A collection, you can put stuff in. There's an add method. Right? There's may or may not be a get method because if it holds stuff in an unorderable manner, you can't get the ith element. Right? But up here, I can define, well, there's a notion of putting stuff in, so an add method. It belongs up here. It's abstract. It's completely abstract. Collection, I believe, is It is an interface. It just defines that to be a collection, you have to have a way to put stuff in, a way to take stuff out, and a way to modify stuff. Right? But how do you do that? I have no idea. I'm going to leave that as a purely abstract class. All of my methods are abstract. I don't know how to do any of that stuff. That's for the subclasses to worry about. Right? And that's what an interface is. An interface is a pure abstract class. You see no code here at all, right? There's no implementation at all. It is 100% abstract. It's not wrong to put abstract, but it's implicit. You don't need to do that. Right? Stylistically, it's kind of wrong to do that. But you also have an interface. The way that you use an interface is a little bit different. I could take that abstract declaration away, and I can say that a bank account implements an interface, bears interest. Right, there we go. And what that has the same effect that I just had of making sure that every subclass has a get annual earnings, get annual earnings, get annual earnings. Right? Now, why would you want to do this instead of an abstract class? It allows you a little bit more fine-grained control. Right? And what I mean by that is not all bank accounts bear interest, right? A checking account does not bear interest. So maybe we can change this around a little bit and say that a savings account implements bears interest, and a money market account implements bears interest. So those two type of accounts have a get annual earnings method. And now over here in the demo, I can't do this anymore because this is a generic bank account. But what I can do is I can have a bears interest account. Foo is equal to, what is it? Checking account, C. There we go. And then I can go foo.get annual interest. Right? Oops, C is a checking account. No, checking accounts don't bear interest. A savings account. There we go. Right? No. Savings accounts bear interest. What are you complaining about? A savings account is, because I didn't save it. There we go. And now it's not complaining anymore. I just didn't save. Right? So so I've got this whole hierarchy now. And what we'll do next time is I'll give you a demonstration of what this hierarchy looks like. But before we do that, I want to talk a little bit about how this actually works under the hood. It all happens with what's called a virtual table. So with inheritance, a class may be referred to as its superclass. Right? So for example, and I'll go to the ostrich bird example here. What I could have is Java. I could have a bird, B, is equal to a new robin. Right? And if I call this b.move, let's just say that it prints out how does a robin move? It flies. Prints flying. Right? And if I have another bird, O equals new ostrich. Right? I can refer to that bird B2. There we go. B1 and B2. B2 dot move. Right? This prints. Well, what does an ostrich do? Or runs. Okay, runs or walks. I forget which one I did. Right. All right. So how does it know that it should call this method that calls flying over here? How does it know that when you've got a bird, a generic bird, and it calls this move method, how does it know which method to actually call? For example, over here, I've got bears interest foo, right? And then I call foo.get annual earnings. Right? If you're a dumb compiler here, you don't know, well, what is foo? Right? In fact, that's why you use the variable name. It's just this generic thing. How does it know that it calls this method that compounds it quarterly versus this method over here in the savings account that compounds it monthly? Monthly or quarterly? How does it know? Right? And it's something called a virtual table. Right? To determine which method actually is called, Java uses what's called dynamic dispatch. Right? Remember way back at the beginning I said that object-oriented programming is distinguishable from other forms of programming paradigms because it relies on message sending. And I said that you're not really invoking a method. You are actually sending a message to the object to invoke its move method in this case, or its get annual earnings method. Then it takes care of which method actually gets called, right? Its own method. Right? And that's what dynamic dispatch is. A message is sent to the instance object, and the object determines which method actually is called, invoked. That's called dynamic dispatch. Dynamic dispatch is achieved through a virtual table. A virtual table is simply a table of references to methods created at instantiation. Instantiation being when you create a new object with a new keyword in Java. All right? Now, to demonstrate this, I'm going to bring up a really quick diagram that I did. Let's see, where is it? Inheritance? Nope. Nope. Where are you? I named it the bird diagram. There we go. All right. Here's the bird diagram. I've got an ostrich and I've got a robin. Charlie's the robin. Sweet D is the ostrich. When Charlie calls the move method, he's a robin, so it prints out flying. Sweet D, when you call that move method, it prints out, it's an ostrich, so it prints out walking. Right? These are the virtual tables. When you create Charlie here, it's got a move method, and it's also got this fly method. This reference is referencing the actual fly code, system.out.println flying. The ostrich, when that virtual table is created, its walk method, its move method, that should be up here into the move. Move method is referring to this method over here. Right? It happens at creation, at instantiation. These are tables, right? They're virtual tables because they're actually references to other methods within in memory. Right? Oh, I thought that would go over a bit better. Right. Nobody watches It's Always Sunny? No? Oh, okay. You're missing out. All right. All right, so your assignment then for today is to go through all 12 or however many seasons there are of It's Always Sunny in Philadelphia. All right. So that's how virtual tables work in object-oriented programming. Sometimes, however, you may not want a class to be subclassed. Right? You don't want anyone to create or extend the behavior of a class. Why? You may not want them to change established behavior. Right? For example, let me go ahead and come over here and let's create my own integer class. My integer. There we go. And what I'm going to do is I'm going to redefine an integer so that it's actually a double, right? Private a double value, right? So does that sound like a good idea? Or maybe complex values, right? Private Boolean is complex. Right? So what I'm going to do is I'm going to extend the Java integer. Now, first of all, before asking whether or not this is even possible, is this a good idea? Should I be, everybody in here understands what an integer is, right? It's a whole number. If I go and change what an integer is, I can do all sorts of really bad things, right? Design-wise. This is not security-wise. I could change it so that plus is minus, right? I could change it so that multiplication actually always results in 0. Or if it's a double, I could change it so that it slightly, changes it so that when you multiply a double, there's always a round-off error. And if those round-off errors correspond to cents, I can go ahead and redirect that to another account and millions of transactions a day, and you've got the plot to Office Space, Superman, a bunch of other things, right? Where you're stealing money now. Obviously, this is probably a bad idea from a design point of view. Everybody knows what an integer is. Everybody has an expectation of how an integer behaves. We don't want to be going and changing everybody else's expectations. So Java, or at least the Java language, not the language designers, but the library designers have prevented me from doing this. Right? Let me go ahead. Let's see how. Type my integer cannot subclass a final class integer. So the way that they did this is by making a class final. And am I going to be able to do it here? Probably not going to be able to make a class abstract and final. So let me go ahead and make it, I don't know, money market account. I can make this into a final class. The final keyword means that this is the end, right? I don't know if it's done in the collections library or not, but if you didn't want anybody making a subclass any further down in this hierarchy, you could make all these stubs into final classes. That's final, right? It's done. You cannot subclass it any further. I'm going to prevent you from doing that by slapping the keyword final in front of it. And that's what Java has done for integers. It's prevented anybody from extending and changing the behavior of those classes by using the final keyword. So at this point in Java, you can prevent someone from extending your class by making it final, using the final keyword. Other uses of final in Java. What's one other use of the final keyword that we've seen before in a different context? Yeah?
Make something a constant.
Making a variable into a constant. Makes a variable into a constant, right? You cannot reassign the variable. Right? The other use is a method, right? Using the final keyword on a method prevents subclasses from overriding the method. I'll put that into italics there. When you've got a subclass that changes the behavior of a method, that's called overriding. So to prevent that, you can. I want you to extend these things. The hash set, yeah, you can go ahead and make a subclass there. But there's this one function I do not want you to change. There's an expected behavior on this function in the hash set that if any subclass changes it, it completely breaks the idea of what a hash set is. So what I'm going to do is I'm going to make that method final and allow you to go ahead and extend the entire class if you want. For example, money market account, let's say, if I make this final, right? This is just a toy example right here. Putting a final keyword in front of a method means that if I were to make a class that, now I can't do it anymore, but I'll keep that just for demonstration. But if I made I don't know, a super special money market account extends money market account, I would not be able to change this method. It would always be quarterly. So if you want use of the keyword final here, if you want to create a constant variable, well, that's a contradiction in terms, but if you want to create a constant, you use the final keyword. If you want to create a constant class, something that can't be extended, that can't be inherited from, you make the class final. If you want to have like an in-between where you've got a class and you want people to be able to subclass it, but there's this one method in there that you do not want them to touch and change, you can make it final. Right? And now maybe we understand a little bit more on toString. ToString is inherited from the object. Java is a singly rooted inheritance hierarchy. Everything automatically extends object. Everything has a toString method whose default behavior is, remind me? What happens if you don't define this toString? Let's find out. Yeah, okay. What's going to happen? It prints out the fully qualified path, blah, blah, blah. And this thing right here is the Java virtual machine address. That's the default behavior provided by the object class. Only when you change that, and go back to bank account, and override that method, does it provide more specific behavior. that a bank account will print out the account ID followed by the balance of the account. Right? And that gets inherited by all of its subclasses, the money market account, the savings account, everything else. Right? So code reuse, but in a much larger design kind of context, where you can define the most general behavior up here, and then you can inherit it automatically